Have you ever wondered what ties together the apps on your phone, some of the biggest video games in the world, and the giant systems that run global businesses? Well, today, we're going to pull back the curtain on the programming language that's often the powerhouse behind them all: Java. So let's kick things off with a little bit of a puzzle. Think about these three things for a second: the Android apps you use every single day, a world-building game like Minecraft, and the kind of heavy-duty software that huge companies rely on. What's the one thing they all share? You got it. The answer is Java. It's a language that's so deeply woven into our digital lives that we interact with it constantly, and most of the time, we don't even realize it. All right, so here's our game plan. We'll start with the big picture of what Java is. Then, we'll pop the hood and see the engine that makes it all work. After that, we'll actually break down your very first program. And finally, we'll see how you take that code from just a file to a running application. Okay, first up, let's get a solid handle on what Java is at a high level and, why it's still so incredibly important after all these years. So what is Java really? Well, at its heart, it's a high-level programming language. That just means it's designed to be read by people like you and me, not just machines. It was born back in 1995 with some really powerful ideas in mind, like it should run on any computer and it should be built around this concept of objects. And that idea of versatility, it's no joke. I mean, we see Java absolutely everywhere, from game development and cloud computing to big data and even AI. It's also a huge deal in the Internet of Things and, of course, mobile apps. And this right here, this leads us to the core philosophy, the secret sauce that made Java a revolution. Write once, run anywhere. Just think about that. You write your code one single time, and it just works. On a Windows machine, a Mac, a Linux server, no changes needed. This platform independence is really the key to its massive, lasting success. So how in the world does Java actually pull off that run anywhere magic? To get that, we need to take a look at the engine humming away under the hood. So traditionally, you had two main ways to get your code to speak a computer's native language. On one hand, you had compilers. They translate your entire program all at once before you run it. On the other hand, you had interpreters, which would translate and run your code one line at a time. Both have their ups and downs. But Java's solution was just brilliant. It's called the Java Virtual Machine, or JVM. The best way to think of the JVM is as a clever middleman. Your Java code isn't compiled directly for Mac or for Windows. Nope, it's compiled into this intermediate language called bytecode. Then the JVM on each machine acts like a universal translator, turning that same bytecode into the specific instructions that computer understands. That's it. That's the trick that makes write once, run anywhere a reality. All right, that's a no theory. Let's be real. The best way to learn any language is to see it in action. So let's dissect your very first Java program. And don't worry, we're going to take it piece by piece. And here it is. This simple little program's one and only job is to print the sentence "first Java application" onto the screen. It probably looks a bit strange at first glance, but I promise, every single piece here has a very specific purpose. First, let's look at that word class. In Java, everything lives inside a class. The easiest way to think about it is like a blueprint for something. It defines what it is and what it can do. In this case, our blueprint is just named skeleton. Okay, now for this long line: public, static, void, main. This whole thing defines a special kind of method. This is basically the front door to our program. That word, main, is the specific name the Java Virtual Machine looks for to kick things off. Every runnable Java app has this exact entry point. It's the starting line. And finally, the action. This line right here is a statement. It's a command that tells a computer exactly what to do. System.out.println is a built-in command that pretty much just means, hey, print this line of text to the screen. And the text we want to print? It goes right inside those parentheses and quotes. So you see, when you really boil it down, even the most gigantic, complex software is just built from these fundamental pieces. You've got your keywords, like class, your identifiers, which are just names you make up, like skeleton, and your statements, which are the commands that make things happen. Now that we've actually seen the code, how do we run it? Let's walk through our final section, taking your program from a simple text file and actually bringing it to life on the screen. Okay, bringing this code to life involves a few key steps. You write your code and save it as a .java file. Then you use a command terminal. First, you use the compiler, Javik, to create that bytecode we talked about. And the final step is using the Java command to tell the JVM to run that code. Now, I know, it looks like a lot, but don't worry. Modern tools often automate this whole thing with just a single click. Before we wrap up, I want you to see this because it really explains where Java's true power comes from. The core language itself, the special keywords you have to memorize, it's actually pretty small, only about 50 of them. But the real power comes from its huge built-in library, known as the API. This gives you thousands of pre-written tools for everything from math to networking to graphics, so you don't have to build it all from scratch. And just like that, we come full circle. All of these pieces, the simple language, that powerful API, and especially the Java virtual machine, they all work together to deliver on this one incredibly powerful promise. Write your code once and be confident that it can run just about anywhere. So there you have it. You've now seen the fundamental building blocks of a Java program, from a simple idea all the way to a running application. You get the promise that has kept this language so relevant for decades. Really, the only question left is, what are you going to build first?